Hi everyone, Mr. Ray here. I'm going to do another quadratic word problem. This time we're going to do revenue problems, okay? And these are, a lot of students will consider this to be the most difficult type. And when you see the first example, you'll probably agree. But the thing that I've found is once you've seen one of these problems, the rest of them are really similar. Just a couple little tweaks here and there. Um, so, what I would urge you to do is follow through this example, and if you still want more examples, go onto YouTube, just do a search on revenue quadratic word problems and see what comes up. Um, there are a fair, there are several of them on the word problem handout, and there's a pretty good chance you'll see one of them on the assignment at the end of the week. So make sure you understand it. Make sure you practice as much as you can. Okay, so uh, we're going to take a question from the handout. So that's one less that you have to do. Um, this one says computer software programs are sold to students for $20 each. 300 students are willing to buy at this price. So at $20, 300 will buy the software. For every $5 increase in price, there are 30 fewer students willing to buy the software. And that makes sense. Like if the price of something gets raised, fewer people want to buy it. But if the price gets decreased, more people would probably want to buy it. So this is like economics, supply and demand and cost and all that. So um, just make sure you understand. Yeah, so the revenue question you get will either be the price is the price is increasing by a certain amount, and every time that happens, you'll get fewer people buying it, or the price decreases by a certain amount each time, and more people want to buy it. So just a minor little change in the equation. I'll show you where that is. Um, so I guess we should finish reading it. For every what is the revenue function that represents this? So this is basically building the equation, and then calculate the selling price that will produce the maximum revenue. And what is the maximum revenue? Okay, so you definitely have to do this with a quadratic model. I've seen some students try to do these questions by just guessing and checking, and it's well, for one thing, I asked you to use a quadratic model, but guessing and checking will not be an efficient use of your time here. So first thing we want to talk about is revenue, because this is a different type of animal question here. You have to understand the concept of revenue. So say I'm selling pencils, okay, and that's all I'm selling. So my revenue, if I'm selling pencils, will be the price I'm charging for one pencil times the number of pencils I'm selling. So that's basically revenue is the money coming in. It has nothing to do with how much does it cost me to make this pencil. It's just how much money am I earning from my sales. Okay, so the revenue is always two things, like I just said, the price per item should be an I there, times the number sold. So and when we read the question, they gave us a price that was charged and how many people were buying it. So that's how this ties in. So currently, if we just left things the way they were, you'd have um, selling it for $20 each, and 300 people are willing to buy it. So that's the sales of 300. So 20 times 300 would be what would be $6,000. So currently, we'd be making $6,000. So uh, that's what it is right now. But we've been told, I guess somebody did a little survey, and out of the survey they said if we increase the price, we're going to make more money, obviously, but we're going to sell fewer. Um, so it's a bit of a trade-off. So which which price would maximize the revenue? So that's what we're going to do here. Okay, so we have to introduce a variable. And it's not the obvious variable. The variable is not going to be what price should we charge, and I'll show you why. So um, I'm going to use n, let n represent, and it's going to represent how many price increases of $5 we're going to have, okay? So the number of $5 price increases. So what that means is, you know, if n is 0, we didn't change the price. The price would still be 20 because that's what it is right now. If n was 1, that'd be one $5 price increase, so $25. If n was 2, it'd be $30, and so on. You could also have a negative for n. We're going to see that. So if n was, say, -2, what that actually means is instead of increasing the price twice, we decrease the price twice, $5 a time. So if n was -2, the new price would actually be $10. Okay, so when n's positive, it's the number of times we're increasing the price by $5. Okay, so let's start developing the equation, and we're going to do it right from this revenue equals price per item times number sold. So this is part A. I'm going to come up with the function that represents, or in this case, the equation that represents the situation. So revenue equals, and in the first set of brackets, I'm going to have the price per item. So basically what I had there, and this will be the number sold here. So currently, we just talked about this. We're selling these for $20, and we're selling 300 of them. Okay, so far we're not really using the n. So let's talk about the impact that n will have on the revenue. So like we came up with examples on this, right? So the price, every time n goes up, every time if n is 1, that means we're going to increase the price by 5. If n is 2, we increase it by 10. So the revenue, the price is going to be increasing every time we increase the price, but the number sold will be decreasing. And it's going to be a multiple of n each time. So what we're doing every time we increase the price, it's going to be $5 times the number of increases. So for example, like we said, if n was 1, the new price would be $25. If n was 20, this would be 60, the new price would be 80, and so on. So that's the price per item. The number sold, this is every time we increase the price once, we decrease the number sold by 30. So that's going to decrease by 30 times the number of increases. Okay, now these two signs will always be opposite. So in this case, the question was actually increasing the price, which causes a decrease in the sales. So you have a plus here and a minus here. If you had a question where you're decreasing the price, so this would be a minus for the price, and this would be a plus here because you'd be increasing the number sold. Okay, so this is our equation, basically done. So this is your answer. I'm going to keep going here. Now, we'll give that value R. Everything else is the same. You can kind of see here that if we actually expanded this, this is like a FOIL here, we will get an n squared term. So that's good news because this is actually a quadratic model now, and that's why this type of question is in the quadratic unit. Okay, so it's a good application for that. So always good to draw a little sketch. Okay, now I have no idea what this parabola really looks like, but you can see that if you multiply the n 5n with a negative 30n, that's going to be a negative n squared. So obviously that's going to be opening down. Okay, so I'm just going to kind of draw a random parabola that opens down. It's not so random, but I do know that it opens down. Okay, so um, this is going to be my revenue. This is going to be the value of n. So as n changes, the revenue changes. And what we want to find is this point right here, which is the vertex, because that will give us the most possible revenue. And we want to find out, well, what's the value of n that gives that? And then once we have that, we can figure out the price, the number sold, and the revenue. Okay. Now, the way that most teachers will teach this, and if you want to do it, it's fine. It's the way that I used to teach it, but it's this question is a lot like, if you remember the what was that? That was the rectangle, the fencing problem. If you've looked at that already, we had something similar where we had basically this is in factored form already. Okay, so what we're trying to find is the vertex. So if you're starting in factored form, you want to find the vertex. We could expand this, turn it into standard form. Then we could complete the square, and then once we have vertex form, there's the vertex, and that's totally fine. But what I've seen is there's a lot of room for mistakes there. There's a lot of math going on, lots of potential errors. Okay, so my approach is exactly the same as with the rectangle, the geometry question. So if I can find where the revenue is 0, these 2 points, if I can find those 2 values of n that make the revenue 0, then halfway between them will be the value of n that gives the maximum revenue. So that's exactly what I'm going to do. And this only really works because it's already in factored form. So if I set that to revenue equal to 0, I can see that the only way that's going to happen is if one of these factors is 0. So I basically set each factor to 0 separately. And when I do that, here I get n equals -4, and we'll talk about what that means. If I set this to 0, I'm going to find that n equals 10. So I've actually got my 2 values of n that give me no revenue, no money coming in. And that makes sense because if you look at this, if we increase the price 10 times, right, that's actually going to cause this to be -300, which basically turns the sales, the number sold, into 0. So if I don't sell anything, it doesn't matter what the price is. I'm making no money. Okay, and the other side of it here, so n is negative here. So remember, if I plug negative in there, that means I'm actually decreasing the price 4 times. Okay, so if I plug a -4 in there, if I decrease the price by $5 4 times, that means the price is now down to 0. So if the price is 0 or the number sold is 0, I get no money coming in. Okay, so that's what these 2 values mean. So I have a -4 there. That's why I kind of drew this curve that way, because I knew I'd have a negative value, and I have a 10 here. Okay, so I'm trying to find that value of n. That is just so now I'm trying to find the maximum revenue, and that happens when n is the average of these 2. So I'm going to n equals -4 plus 10 divided by 2, so that's 6/2, so n is 3. Okay, so I can go back to my picture here, and that's going to be 3. So if I increase the price 3 times, that's going to give me the maximum revenue. So I've almost finished the question, and I haven't really done all that much math. Now, these questions can ask a variety of things, so I'm going to answer all the possible things that they might ask. So that's how many times we will increase the price by $5. The questions rarely ask that, like how many times would you change the price. It's what is the new price, and that's what they asked here, I believe. What calculate the selling price that will produce the maximum revenue. So the new price, remember, if you keep track of this bracket here, that's the price. right? So the price will be 20 plus 5n, but we've already determined to get the most revenue, n should be 3. So if we increase the price 3 times, the new price will be $35. Okay, so we've already answered the question they wanted for B, but let's keep going. Okay, so the other thing they could ask, how many would we sell? So the number sold is the second bracket here. So the number sold is 300 minus 30n, and n is 3 for the maximum revenue. So that's 300 minus 90. So we would sell 210 boxes of the software, or whatever it's sold by. And then the last thing could be the revenue. And in fact, that's what part C asks. So the revenue, you could plug your n back into here all over again, but you've already just calculated this. That's $35, and this is 210. So the revenue is just $35 times 210 sold, and that's $7,350. So that's the maximum revenue. Okay, now, should do a little check here. So remember when we didn't change the price, right? It was just $20 per software, 300 people want to buy it, and we said, well, that would be $6,000. So it's always good to go back and compare that, you know, because your maximum revenue better be at least as high as the 6,000. It definitely can't be lower. So in this case, it's $7,350. You know, that's like $1,300 higher. That seems to make sense. Okay, it's higher. And the other thing to check is it's reasonable. If your answer came back and it was like your new revenue is $2.5 million and change from 6,000, well, that seems a bit extreme. So let's just answer the question. So therefore, a selling price of $35 maximizes the revenue. So that's part B. And then part C, if we go back and look, says, where is it? What is the maximum revenue? Well, we just calculated that. So just to put it into words, maximum revenue, here we go, maximum revenue is $7,350. Okay, so if you look at the math, it's not, you know, it's not a lot of math. It's just setting these two factors equal to 0, averaging the values, and then plugging that value of n back into each of the brackets to get the number sold, the price, and the revenue, and then answer the question that you're being asked. Okay. Now building this equation, like I said, the first time you see it, it looks like some very difficult math, but you can see that these two numbers are always given to you. The original price, the current price, and the numbers sold go in the first position, and then you're going to have a multiple of n for both, and if you're increasing the price, it'll be plus the number of dollars per increase times n, and this will be subtract the number of people that won't want to buy it for every increase times n. Okay, now like I said earlier, if they switched the question around and they were decreasing the price by $5 and maybe 30 people wanted to buy it, then it'd be minus 5n plus 30n. Okay. All right, so hopefully that that makes sense. Like I said, if you want to get more exposure to different questions, you can go on to YouTube, but you're probably going to find that their approach will be slightly different. So getting the equation is exactly the same, so every technique would get that line, but how you actually find the vertex might be different. So I found the zeros, and then the average of the zeros gave me the vertex down here. You'll see a lot of people, a lot of teachers, students will expand this, expand and simplify to standard form, and then complete the square. it's like I said, it's a lot of work, and I think this is a better approach. So if it makes sense to you, please use it. If you'd rather use vertex, change to vertex form to find the vertex, that's fine too. So whatever works for you is fine for me. Okay.